Hello, I hope you are doing well. So today we are going to move next onward in our lecture series, and today we are going to make next word predictor. Like it is same like as your in like a mobile keypad. When you WhatsApp someone, then whenever you type some word, then next word automatically they suggest. Then how they are suggesting that word that we are going to do today. So, and this will be the base and or you can say the foundation of our chatbot. Okay, so let's get started. I have selected one data set for that is this one. Okay, let's download it. I will put the link of this data set and this notebook also in description, so you can access from there. Okay, so let me download it. You can unzip it, just extract it. Let me put the here. Let's extract it. Okay, this is dialog.txt. This file is txt file. Okay, now let me make it smaller, otherwise you can't see it. Sorry, you haven't saw that one, but it's fine. Okay, now it is fine. Okay, so we have downloaded a data set. Now let's upload the data set here. It will take little bit time. Okay, now just click on here and just upload it. See here, it is uploading. Okay, let me use mouse highlighter, otherwise you won't able to see it. Highlighter. Okay, fine. Okay, so this is our data set. If you want to see this, what is inside that, then we can open it, no problem. Let me make it like this. Okay. I think it is fine. See the data set here. How are you doing? It is like a sentence, some conversation. I think this data set, and it is saying I am fine like that. So we will be training our neural network based on this. Okay, so let's first load this data set in our variable. So we have to first open it. Okay, and give the name of the file. That is, can take the file name, just right click here and copy path, and we can just paste here, and we can open it in reading mode as and it is like data. So f dot read we can do. Okay, so it will read all those things and put inside this data. Okay, fine. Let's just check it whether it is okay. We have to close it also. We have to close this file. We have opened and we have closed, and we can just see the data. See, all this data has come here. Okay, so it is how are you doing, then it is /t. That is this like one tag space is there, and you will find your /n. Okay, so that is next line. Okay, so we are going to just remove these two as we don't need this. Okay, so we can just ignore this. So let's replace it. Let's replace /t by, we can say, just by a space, and we can put in our data. And okay, let's run it. Just verify. See, all the /t has gone. See, from everywhere slash t has gone. Now in previous lecture, as we have saw that for the pre-processing tokenization, we need list of string list, like a list of string. Okay, so all this is one sentence. Okay, and after that there is slash n. So we are going to split it from the slash n. With respect to slash n, we can say also. So in data, we are going to just do like this: data dot split. Okay, let me put it next line so that if you run by yourself, then you can see all those things. Data will be equals to data dot split, and we are going to split from with respect to slash n. Okay, so it will split all those, and we can just verify here. Okay, what happened? SELIT, list object has no attribute split. Okay, replace this one. It is not list, data is not a list. Okay, see, okay, fine. So we have got in a list. If you check the data type of this data, then it should be list, I think. So it is a list. Okay, you can see the first, what is the first sentence. See, this is the first sentence in this data set. Okay, so we are not going to use all this data set. Let me check what is the length of this, how many samples are there. 3725 sentences are there. Okay, questions and answer like that. So we don't need all. We can take a small portion of that. Let's take just 500. You can take 1000 or all, no problem. Let me take a small portion. It will be easier to train. Okay, and it will be fast. Okay, whatever. Now we have our data. Okay, we have our data. Okay, fine. Now what we have to do? We have to fit. Okay, we have to do the pre-processing, means tokenization. We are going to do the tokenization, or you can say pre-processing. So we have to import the tokenizer. So from tensor.keras.preprocessing.text import. What we want to import? We want to import tokenizer. Yeah, now fine. Let me make one instant of this object. Okay, let me put in here, or we have tokenizer, and number of words we can pass here, but B may or B may not. Okay, we can find the total number of words later. Okay, let's just put one thing, that this OOV tokens, it means if while predicting some word, okay, if that is not present in this, or in this data set, or that token is not available, then automatically one will be reserved for that. Okay, so let's just put this token equals to OOV. Okay, fine, just run it. Okay, now let's do the fit on text. Okay, and we have to pass here the data. Okay, fine. See, you can see in previous lecture I have shown here we have to pass the text. Okay, now we have passed the text, that is data. And one thing, what can we do? If we want to check what are the word index, then we can just check it fast index. See, indexing has been done. Okay, now we can do what? Now what we should do? Let's fit on text is done. Now we can text to sequence. We can do that part also. So we have this tokenizer dot text. Any suggestion? Text to sequence. Okay, and we can just pass the data here. Okay, and we can store somewhere like sequence. Okay, fine. Let's run it. And if you want to check it, what is inside that, then we can just check it. See? Okay, if let's just check the first sentence. First sentence means, what is the first sentence? How are you doing? I am fine. How about yourself? This one. This sentence is this one. Okay, that can be represented by this. Okay, so this is okay. Now we got the sequence, and since we got the sequence, so what actually in keypad, what actually happen in our mobile whenever we type some word, that take if we type hi, then that will predict the next most probable word which is similar to that, not just similar, semantic to that, which is more semantic to that. Okay, so first if we just type hi, then it will just take input as hi, and if we type hi how, then it will predict r, and if we type hi how are, then it will predict you. Okay, and if we type hi how are you, then it will predict doing. Understood what I am trying to say? So for hi, what is label? How. For how, hi how, what is label? This r. Okay, so we have to prepare the data set from this sequence. Okay, so we have, let's say, sequence, not sequence, sequence in sequences. We are going to take each sentence, means we will take each sentence, this sentence, and we will take hi, and we will actually do what we will actually make n-gram. This is known as n-gram. So we will first put these two together, then these three together, then these four together. Okay, so that I am going to do. Okay, so we have token text, we can see. Okay, now we can do we have each sequences. Okay, now we have sequences, and from sequences, okay, we have sequences. So from each sequence, okay, so we have this list, and from this list we have to generate n-gram. So I think how can we do? First we should take these two, then we should take these three. I mean that that will be our actually input sequence, and let's make it list, and in that okay, so we can do for I in range from 1 to length of this sequence. Okay, we are taking the length of this sequence, first selecting one sentence, okay, then we are we are going to select this first, these two, then these three, like that, and we will be appending in this. Okay, so this is actually n-gram. We are going to n-gram. Okay, so here n-gram will be what? N-gram will be so we have this sequence. Let's take this sequence and we can like slice it I plus 1. Okay, when I is equals to 1, then these two will be like will be put in n-gram, and this n-gram will be appended in this input sequence. Append in like just append it n-gram. Okay, I think it is fine. Is it fine? I hope it is fine. Let's check how is our input sequence. Just run it. Yeah, fine. Let me show you just see this one 359 and 30, 359 and 30, after that 29. So one word is appended, one more word is appended, like this. See, so this is known as n-gram. Understood? So this is n-gram. Okay, so this is actually we will pass this one. It means if this is high, then this is like 13 is representing what, how. So when we pass high, then it should like predict how. Okay, let me just comment it out. You can just run it whenever you want. Okay, now we have to we need what, x and y, and if we see like in this one, what is our x, what will be our x? So this much is x. What is y? Level is y. It means just last one, every last word will be the level of that particular sequence, for that particular sequence. Okay, so let's separate all those. X train, what is this? So we want what we want what is the name of that variable? Let me just check. We have, okay, it is input sequence. From this input sequence, I think first we should do padding. Okay, let's do padding first. And in padding, okay, let me first import it from TensorFlow.keras dot preprocessing.sequence import what we want, pad sequence. Okay, fine. Okay, it has been imported. Now let's add it. Before padding, what the size we want, so let's take the size, padding size equals to what can we say? Okay, what padding size we should take? I think we should take the maximum one. What is the maximum size of a sentence in this one? Okay, so max length of input size. Okay, we are going to take one of these, so we can use the max function, and length of x we can do like this for okay x in sequence, not in sequence, just input sequence. I think it is fine. So it will take x. X means this. It is indicating one sequence. So one sequence, its length, putting in a list and finding which one is like which length is, which value is maximum. So it will return actually the max length. Okay. Okay, let's now pad it. So pad sequences. Okay. Inside that what we have to pass, we have to first pass the sequences. So we have input sequence and we have to pass the max length, and our max length is this max length. Okay, fine. So it is actually our padded input, and this we will be using actually. Okay, fine. So it is our padded input. Actually, how it will look like, let me just show you. See, it has been padded. You can just see the first one. See, this is first one. First one means what? Which one? 359 and 13. That is representing these two. Okay. Okay, fine. Let's split x and y, x train and y train. Here we should not give name x train. Actually, it is not x train. Where is that? Where that one? Okay, I haven't give any name. Actually, our x train will be what? What will be our x train? Just this much. 13 is our level actually for this sequence. Okay, so we have padded input, and in that padded input, what we want all those. Okay, let me show you how the slicing is working. Okay, so it is like first this one, like sequence. In that first sequence, I want only this much. So what I will do, I will just slice it. How I will slice it? Like this. See, 13 has not considered here. So same thing I am going to do here. 0 no? We have just done do it for 0, but we want for all this. Okay, not just for only one. So what we will do, we will do like this. So this one will be this one is saying slice all, and this one is saying slice from where to where. Okay. So actually it is our x train. Just run it, and then what will be our y train? Y train will be this one, all this, and last one. Last one means this 13. Okay, let's run it, and we can check also. Or we can take it. See, and we can check for the first sentence, first sequence. First sequence is this one, and its corresponding level is. Its corresponding level is 13. Okay. Okay, fine. Now what we have to do, our x and y are ready. Okay, x and y are ready, and one thing we will be like we will need, that is total number of words. Okay, so how we can find that one? So total number of words we can find like we have this tokenizer. Okay, we have this tokenizer, and if we do like word index, then it is showing all the tokens. Okay, let's do it like length of this word index. So 587. Okay, so let's just copy it. It means that much words are present in our data set. And we have to add one more. That one is, just remember which one. Which one is that? This one. Okay. For this one we have to just add it. So total number of words we got. Now everything is ready. We got the total number of words and we got the x and y. Fine. So what next? Let's implement our neural network now. We will be using a recurrent neural network for this one. Okay. And first thing, like here we have x y train. In y train it is just showing 13. So it is like we should do if we do like we are passing this one, then it should predict 13. How it will be? It should be like a regression model, but regression will not perform very well. So what we can do something else. We can do like one hot encoding. So what is that one hot encoding? Like in a one hot encoding, let's say there are two classes. There are two classes. One is S and another is no. So we can write like this. Let's say there is some sentence which answer is S. So we will write like this: 1 and 0. No is like a 0. And if there is like one question and that answer is no, then how we can do that? 0 and 1. Understood what I am saying? This is one hot encoding. Okay, so let's do one hot encoding on this white line. So one hot encoding. Okay, for that we are going to use the TensorFlow. Let's first import TensorFlow. Import TensorFlow as TF. Just run it. And TF dot what is that? That is in keras. Okay, and that is inside utils. And we have to like we are doing categorical. Okay, so in this one it will do like hot encoding. Okay, so what we have to pass here? We have to pass y. See, so y is y train and number of classes here. So how many number of classes should be there? Number of classes means like here yes and no. So here like its size is 2, but here like any word can be like possible label. So here number of size. Okay, number of classes will be total number of words. Okay, so number of classes will be equals to total words, isn't it? Yeah, it is. Not isn't it? It is. It will be, because any word can be a label. So we have total words. That is our level. Like that was I think 587. So here 587 level can classes can be. Okay, just run it. So it is like returning this one. We can store it like just update this white line. Just run it. Now fine. Okay, now we can implement our recurrent neural network. We are going to use the LSTM, long short term like memory. So what is a recurrent neural network? You can just search here RNN. Let me just show you an image. So what is like in recurrent neural network, we pass this x1, x2, x3. That is like our sequence. One sequence, like one sentence having one sequence. No? Sequence, I mean this one, 0, like these are we will be passing here. Okay, and that value will be passed. These are the nodes. Okay, and here will be weight and biases, and these are our labels. Okay, So labels means this one white rem. Okay, so these are labels, that is like y. Okay, actually this is not label. After that there is like output, that output is label. So what happen in like a recurrent neural network? In recurrent neural network, let's talk about this cell. This cell takes the state, like value from the feedback from this previous one and this value. Okay, and then it predict then it compute this h2. Okay, and it also pass the feedback to this this one. Okay, so it actually this way actually recurrent neural network will be able to find the semantic in a word. Like you can say this is a cat, so this is a cat, it is fine. Okay, so how you how the computer will know a sentence should be in form of subject, verb, then object. Okay, so those things can be maintained from this recurrent neural network. Okay, but there is one problem with that. Big problem is that if this size is very large, then if you think about this accent, so impact of this x0, feedback coming from this this cell will be very low at here. Okay, that's why we use long short-term memory, that is LSTM. Okay, I think somewhere will be you can read about that LSTM. Just we are going to just use that. Okay, and yeah, that's it. So let's implement our model implementation. Like we are going to implement RNN, recurrent neural network. Okay, fine. So we have model. Okay, so we have tf.keras dot sequential. In that sequential, first layer will be of embedding. Of course, it will be embedding. Okay, we are dealing with this text. Okay, NLP, we are dealing with NLP, natural language processing. So be using embedding is very nice because it reduces the dimensionality and also find the expect the important feature. Okay, so let's first define this embedding layer. tf.keras.layers.embedding. Embedding, give me suggestion. Okay, so in embedding we have to first pass the input dimension. So what is our input dimension? That is, our input dimension will be total number of words. Okay, so our input dimension is what? Total number of words. Any suggestions? Okay, and what is our output dimension? That we can decide. Let's say we had 587 words. No? So what we can think let's 587 words was there, total 587 words was there. So 587 words can be mapped to this let's say let's take 16, not 16, let's say 30. Yeah, fine, anything can be fine. Or 120. Okay, let's say 120. You can change this value, there is no problem. After that, what we have to define this input length. Okay, so input length. Okay, so what is our input length? Input length means this length, this thing, it is talking about this thing. Okay, so what is our input length? That is this size of this. So what is that size? That size is max length. That is whatever we have defined in padded. while doing padding we have defined, but there is one thing, like we have removed the last one. Like in padding there was 13 also, but in while like in action 13 has been removed, so we have to decrease one size. Okay, so -1. I think it's fine. Okay, let's remove it. Okay, now what we have to define, now we can define the LSTM, and we will be using bidirectional. Bidirectional, I mean, like I said, for this one feedback of this will be like negligible, okay, if we don't use LSTM. Okay, but if we like it is feed forward in this direction. If we are using just LSTM, then it will this action, like this cell can take the feedback of this one, but this cell cannot know about this one much. Okay, that's why we can use like bidirectional. So in bidirectional there is like one more like feedback, so feedback coming from both like cell will be passed. Let me show you just bidirectional. Okay, just see this image. See S0 going like this in forward direction, then this one is reverse direction. Okay, so feedback is coming back and forth. Okay, so we can define our bidirectional layer dot bidirectional. Okay, in that we have to define this LSTM, keras dot layers dot LSTM. Okay, we have to pass the unit, so how many units we want. So let's say 150 or anything with whatever you want. Okay, and at the end how many like output will be. Let's just say pf dot keras dot layers dot dense. In dense how many units we want. So just tell me how many unit we should put. It is output layer, so how many units should be. Okay, let me tell you that here in like white train, size of white train will be the the output size. Okay, so white train is now one hot encoded, so its size will be the, like here total number of words is the size of like white train, not white train, size of a label. For a sequence, the label size is like total number of words equals to the total number of words. You can say something like that. So total number of words, you can put here a unit, no problem. Unit that was showing now there, I think that is units. Okay, and after that we can like put activation function. So what activation function we should use? We should not use those sigmoid function. Yeah, there are multiple like categories, classes. Okay, so for multi-classification we use usually we use softmax. Okay, so we are going to use softmax. Okay, fine. What next? I think it's fine. Our model is ready, and now we can compile it. Okay, in compilation what we have to do, we have to pass the loss function. Okay, so what loss function we want? I want categorical cross entropy. Just open it. Okay, and just copy it. Don't hesitate to copy. Okay, So just copy it, and after that what we have to pass, we have to pass the optimizer also. So what optimizer we want? Okay, we will be using Atom. So either you can write like this only, or you can just search it. ADAM, Atom optimizer. What is the name? Okay, just copy this much. Okay, now in a variable we can put the optimizer. What happened here? Okay, this is our optimizer. Okay, and here we can like define the learning rate also. Learning rate. Okay, learning, LEARNING rate. Okay, how, what, like by default it is 0. See, by default value is this. Let me change it. There is no problem. 0.5, let's say. And here we can just write optimizer, and after that we can define one matrix. In matrix we will be observing accuracy. We want to observe the accuracy while training. Okay, fine. Accuracy. Okay. Spelling is fine. No, what is wrong with this? Anything? RACY. Invalid keyword compile by model dot compile loss equals to this one, optimizer matrix. I think it's fine. Accuracy. What is wrong with this? Valid keyword argument including cloning. Let me just see. Optimizer. It is fine or not? Optimizer loss, and after that the matrix. Oh, matrix it is. Sorry. It is matrix, not matrix. It's fine. Okay. After that we can just our model has been compiled. Now we can fit it. Okay. So we can pass x. What is x? X train. What is y? Y is y train. And how many epochs, like iterations we want? Epochs. Let's say 10. I don't want to give it more time. And anything else? Okay, fine, this much. And if we want to trace the history, how those things are going, we can plot the like accuracy also in graph. So let's import. It is training. Let me import the matplotlib for plotting the accuracy graph. And here we will be predicting, just taking, and in the next one plotting accuracy. Okay, in plotting accuracy, what we have to do? Import matplotlib.pyplot as PLT. I think no error or any error. Oh, that one is running now. Okay, let it be trained. Let's wait. It will take more time. One thing more, like, okay, let me pause it. Here we can give the batch size also. Batch size means at a time 20 or 30, whatever we are going to give. Let's say 40 at a time. 40 sample will go for training. Okay, it will be little bit faster, and also it has the batch size also help like in not in, like it avoid little bit it will help you to avoid overfitting little bit. Okay, in first round, see, accuracy is 18%. After that, 22. Let's see how much accuracy we will get at the end of this training. I don't know how much we will get, but let's hope at least 60 or 70% we should get. That much I think we deserve. Otherwise, you can just change here the learning rate and all those things, and you can check. Okay, this has been done or not. And for plotting, we will be doing like lt.plot. In that plot, we will be passing this history. Let it first run, and here we have to predict. For prediction, we need like padding. First, we have to we need this one. What we need? We have to pre-process now. Otherwise, we have data. No, we don't have. Fit on data. We need this one. Let him copy it. We have to change the sentence, like string to sequence. Like we have to tokenize now. So let's take our test data. Let's say hi Hassan. Let's see what it will give in result. Okay, so here we have to pass this one, and after that okay, after that we have to add it. Just copy it. Okay, copy and just paste it here. And while pasting, fit on text, not text, text to sequences. I think it's fine. Then we can test sequence, and this sequence we have to pass here, and this is for padding. Okay, now fine. And this padded input we will be using. Okay, so in next line we will do like model dot predict. In predictor we have to pass x. That will be this one, added input. Okay, so okay. Oh, it's very bad. Accuracy is very bad. Okay, we got only 26% accuracy. Okay, that's fine, but you can do what? You can just change here like learning rate. Okay, just change it here and just check for which like learning rate we are getting good accuracy. Okay, you can do that. Let me just let me just run it, because time is going very fast. Test tokenizer text to sequences. Okay, now here what is problem? Model dot predict, and okay, let me just first check what is what is this inside this? Okay, oh, it is 2D array, no? We want just 1D. Guys, don't do this mistake. Still we are getting, what is mistake? Padded input, mask sequential predict function is the function. Okay, so we have this one, and here in predictor, okay, we have to pass x. Okay. Are we missing anything? Batch size, I think. I don't know why it is like this. Model dot predict. Everything is fine. Still we are getting error. What is wrong? Okay, so what we was passing in x10, that is also array, both are same. So why we are getting error? Okay, let me just check it and I will, otherwise. Okay, so what mistake we have done, like here when we was passing that like x in training, that we have done like we have removed one element from the last. So we have to while doing padding, we have to do like here -1. Okay, size of these two has to be matched. Okay, if you want, then you can just take the size, no problem. This dot size 27 and size 27. Now it is fine. If you don't do -1, then it will be 28. So that will not match. And here you just pass this padded input and let's run it. See, this much value we are getting. Okay, so e to the power -15, like that. That is 10 to the power -15 kind of values. So if you sum up all these values, then it will be 1. So we have to find which one is like maximum, just maximum one. So let me predict, put in this one, and let's say we have put in high. So what value we have got? So let me just np organax. Okay, in NumPy there is there is one method. Let me import first NumPy as np. Okay, now NumPy has been imported, and we can use np dot arg max. So we want maximum, and we have this predict. Okay, so that is, it has written like 13. So index is 13. It will return the index of the maximum value. Okay, that is 13. So 13 is what? If you see in tokenizer dot index to word, index word, and we can just pass here 13. Okay, I think, okay, 13. Okay, see, yeah, we got the right answer. For high, its next word is, predicted word is how. Okay, so for for like here we can put anything. I am fine, what about, okay, let me put just this much, just run it, let's see what we have got. We haven't got anything. Okay, test data, add import. Oh, we are doing every time importing. Okay, 324 for I am fine. What is next word? That, let's see, that is how. It is saying how. Oh, sorry guys, here we should take like index, predicted index. I should write predicted index. I haven't changed the value. We are getting this. Oh, yeah, net. Oh, it is saying I am fine. What made? I don't know what it has predicted, but fine. Okay, so since accuracy is low, so you can just change the learning rate and all those things. So it will probably we can get better accuracy, and we can like. Okay, so that's it in this lecture. So this in the next lecture I will like show you how we can increase the accuracy also. Okay, and after that we will be implementing our chatbot. Okay, and in that chatbot the same concept we will be using, and but there is like a catch, how we can make chatbot from this using this code only. Okay, so there is a catch. Okay, I will tell you in the next lecture. Okay, and about this history, about the plotting. So let me just show it, otherwise you will say he didn't show me. So we have history dot, in history there is another history, and in that history there is like accuracy and all those things. I think no. Okay, let me just check what is inside that history. History dot keys. Okay, we have loss and accuracy, so we can okay, let me just check over here. Accuracy on terminated string. Sorry. Okay. So only we have done 10 iterations, no? That's why it is showing 10 values. Just use it, otherwise we can say why. Run here, and here we can pass y. Do you know why we were getting? Due to this one, due to that one, unnecessary. Oh, what accuracy. See, at iteration 0, 2, 4, 6, 8 and at 10 we got the accuracy of 26%. But I hope you will get a better accuracy than me. Just change the learning rate and all those things, and just check what accuracy you are getting. Okay, and actually we can use this all this code at this particular lecture to make one API. Let's say you are making one like one website. In that you are taking form. Okay, someone is typing something, then in that you can use this like you can, whenever someone is typing something, then that all those that sentence, that input sentence, every time whenever something is changing, every time you can pass that sentence to this neural network. It will predict what will be the next possible word. Okay, since we are getting here like what are the possibilities when we are predicting here, then we are getting let me show you what I am trying to say that see here we are getting a probability of occurring 0, first one, second one, third one, like that. Okay, so you can put like if the accuracy list all those text are possible out, like predicted values, like predicted word whose accuracy is greater than 80%, something like that. That thing you can do in your like a web project or app project. If someone is if there is something where someone is typing something, then you can add this functionality. It will be very nice. And don't worry, we will be using this code to implement our chatbot. Okay. Then thank you for your time, and I will see you in the next lecture. Okay, bye bye, take care, bye bye.